welcome to my talk, Exceptionally Bad, the story and the misuse of exceptions and how to do better. Okay, this is the slide I put up because my company wants me to put up a slide from Bloomberg Engineering. So yeah, I work in Bloomberg, but who am I? Who is this dashing young dude up at the front? Well, I started coding professionally in C++ in 1991, so I've been doing it a long time, back in the old days of C-front. During my professional career, I've done a lot of system analysis and architecture, and I spent 21 years as a consultant before I joined Bloomberg permanently, which meant I've seen a lot of different companies, a lot of different teams, what worked, what didn't work. And I'm currently in Bloomberg leading the Linux migration of ticker plants. So that's all the data that we feed out as tickers to the Bloomberg customers. So when I come to a talk, what do I like to do? Well, I like to take a talk that I call focused on practical software engineering. It's based in the real world because that's usually where I program and work. And I'd like that the talk has something that you take away and use, whether it's changing your mode of thinking or it gives you some engineering principles to run your own projects by. Okay. So I have a lot of slides. First time I think I've got that. This is the highest slide count I ever had. There's a lot to say about exceptions. But at times where I stop and say, anyone questions, give me a slide number, because it's going to be really hard to figure out, oh, it's the one where this was going on. So they're in the bottom right-hand corner, right? And you have pens. I don't know if you have notepads. You can write on your glass holder, the little thing for your glass. All right, where will we be going in this talk, right? This is going to be an easy talk, no controversy with exceptions. We're going to talk will be about exceptions as seen in C++. We will maybe talk briefly about other languages, but it will be mainly in C++. We're going to look at the history and the original goals. What were exceptions supposed to give us? What were they supposed to deliver? Why did we bring them into the language? And then we're going to look at the mechanics of catch-throw, or throw-catch, because you need to know how it works to have some appreciation of what's going on and why you should be using or not using exceptions. Then we're going to look at exceptions in both their use and design. All right? And hopefully when we've done this journey, we'll have better thinking on the handling of our use cases, right, via exceptions or maybe some other mechanisms. And then we'll think on what I call whatever's left over will be the truly exceptional. All right? And that should give you better thinking on the design of exception classes that you use in your own day-to-day work. However, this talk does come with a disclaimer, right? It may be controversial. I have the bad feeling that I will annoy both the pro and anti-exception crowds. So I think that's probably a good result. All right, so one thing I want to start about exceptions, again, I want to adjust my thinking, give myself a sort of guidelines to be inside of, is what is an exception? The things to note about them, there is no exception class attribute or keyword. There is nothing that says this is an exception class. It's anything you want it to be. There's no formal definition of what an exception is. There's no characteristic that you can look at. I'm not talking about name. I'm talking about how it works to say this is an exception. So again, that makes me think that the use is the primary characteristics of exceptions, how they get used. So with that, let's go on to the exceptional ideals. What were exceptions meant to give us? What was the whole idea? Well, we can go back in time and look at the man himself, Bjarne, and what he said in his design and evolution, what were exceptions supposed to give us? So it's give us type-safe transmission of arbitrary amounts of information from a throw point to the handler. What that means is we're not doing callback stuff where we throw void pointers around and recast them. The second thing, they wanted no added cost in time or space to code that does not throw an exception. I am not aware of us having met that objective. We either give up one or the other, or both. A guarantee that every exception raised is caught by an appropriate handler. We do not have this. This was, I guess, thrown out as too complicated. We did try and do throw specifications for some amount of time in the code, but they got deprecated. Completely unfeasible. Then we needed a way of grouping exceptions. The idea was there's torrents of exceptions being thrown of all little itty-bitty types, and we want to handle them in a generic way. So what we'll do is we'll have a way of grouping them, and that's using the polymorphic type hierarchy. We wanted it to work correctly in a multi-threaded program, so when you throw it in one thread, it stays in one thread. And a mechanism, and this was important in the early days of the language, a mechanism that allows cooperation with other languages, especially C. In other words, I might be in a C++ code that throws an exception. That was called by a C or Fortran piece of code, which was called by a C++ piece of code, which has the exception handler in it. So it has to be able to travel through other code. So that was an important design decision. As we know, we sort of modeled C++ as like C with stuff on it, with classes. And it says here most of these were, the other 7 and 8 don't really mean anything, but it says most of these were, right, gone. So that's back when they were bringing them into the language. So what do we actually get them now? Because things change, right? Other people got involved. Bjarne wasn't the sole narrator of this. So we say, what exceptions give us? Give us an easy to read happy path with a lack of clutter in the code. Now, there's a lack of clutter in the code if you don't use try, catch blocks all over the place, right? It's the absence of these that gives you a lack of clutter, right? Not the 3-word throw, catch, right, stuff that we do. The couples error reporting for error handling, we have that. We don't have to handle an error where it occurs. We can send it up someplace else. They can't be passively ignored. I think they can be passively ignored. You just pay a heavy price if you ignore them. In other words, it brings your runtime down. If you're in some runtime where you don't mind coming down, you have a very efficient way of coming back up, maybe this doesn't matter to you. All right. And it's a simpler way for handling constructor and operator errors of classes. So we've had, up until then, we had to say a class is built. It might be a zombie. We have to ask an is valid, you know, some sort of bool function to say, okay. Here you can now throw it directly out of constructor because you can't pass a pair of, you know, what you want and what an error might be back. So this just gives a simpler way of handling this. And it is the modern and recommended way of handling errors in the language. I present you the evidence, and it's endorsed by standard library, right? So it must be good. Right. So what do I mean? Let's just, you know, I know you guys are very erudite in this, but let's give an idea of what goes on here. So I have a class that has to return a status function. Now, I have a class, this is me and my current age, right, here. And what I'm doing is I say, are you valid or not? And if you're not valid, I'm going to exit out here. Otherwise, I'm going to apply something to the class, and then I'm going to say, is it any good? So this here is a lot of clutter. And when you're trying to find out what the real operations are versus what's catching all the errors, it can be hard to find. So what will exceptions give us? Well, it gives us a function signature change where we don't need to pass status back, right? Did I really need to change this? No, I could have left it the same way, but that would be very bad design where people look at the code expecting a status to come back and you're really throwing exceptions. So when you're using exceptions, you really need to have control over both the throw and the catch side of things. All right, here we have the happy path that's very clean, right? I just say my class, me, if I give it a blank name or a 0 age or a negative age, it will throw an exception. And I can do the apply and say, if there's anything wrong, it gets caught down here. So it's really nice. Now, the path is clean only if you look in between the try. Right? Outside of that, it's kind of ugly. What's wrong with this code?
It didn't control flow?
No. I'll bring your attention to the fact I'm in the main function here. What's the problem? You can't answer. You've seen that before in a try run. All right? This can take my class down because I can't passively ignore. Well, I can. But I'll need something like this, an exception swallower. What this tells me is there's something out there. I don't know what it is. I don't know what the ramifications are of it, but I know it's there. That's really all I know. And really here is where you don't want to be doing most of your error handling, right? This is kind of just a catch-all, and we need to put them in the code. So here's what exceptions now give us. It's not an exhaustive list. It's just what I call the man on the street would want to know. But most applications, certainly most applications I work in, need one of these exception swallowers because we can't have production just going down because a stray exception or a new exception type get added to the code that made its way right the way out into main. So what is any comment on that? All right, next section. Exceptional definitions. What is an exception? Surprisingly tricky to nail down. And I'm going to look at it from a few viewpoints. So the first viewpoint is the mechanism of a behavior-based view. An exception is something that gets thrown and gets caught. That's more or less we have an exception handling mechanism, not really an exception stuff in C++. So let's go and take a look at this. So as far as throwing exceptions, let's take a quick, brief look of how exceptions work, right? And most of this I got originally off, I was at a talk here many years ago for Andreas Weiss, who's in the room. And I wasn't very happy with exceptions then, and he gave me an hour talk on what the mechanics were, and I came out even less happy. And there's been a smoldering burn for the last 4 or 5 years of needing to give a talk like this, and here we are, so thank you, Andres. All right, so when we throw exceptions, the memory for the exception object is allocated in an unspecified way. This is from the standard. But what this means that no matter what you throw, even if it's an int, you have to allocate it on the heap, right? And that can be expensive. And you're outside now of the regular efficient return of variables from your functions. You also need a separate stack unwinding mechanism. All right, you're coming out of this stack and you need to hit the destructors. All right, so you need a way of unwinding the stack, and that's done today in 2 ways. There's a frame-based method where to decide what happens is it has a linked list of stuff it needs to destruct, and as it's going in, adds and takes stuff off. This method means that even if you're not throwing exceptions, you're paying a price in computation. The other way is table-based, where at compile time, you compile all this table of what objects need to be destroyed in any particular range of the instruction pointer. So as your instruction pointer is moving to the code, you hit a throw. You go into this table, you reference into where am I in the range, and then you follow and do the mechanism. It's kind of expensive when you actually need to do an exception handling. But if you don't pay a price in speed, you just pay a price in code bloat. There's a lot of code and tables in your code, right? Let's talk about the catching exceptions. So one thing, I don't know, it's never really said anywhere. Yes?
A question about the 2 different kind of unwinding. Is it based on what compiler, on the compiler?
Yeah, I think Microsoft used to use the frame-based, and now we've all more or less gone to table-based because you don't pay the price if there's no exceptions thrown, which is a fairly dicey proposition to go on.
But it's not something that is an option for someone to pass to the compiler?
No, it's baked into the compiler. All right, so an exception handler can actually only throw somewhere backwards into where it's already been. You can't throw sideways or forwards or anything else, right? It's got to be somewhere you've already come from. We need to do this polymorphic catching of exceptions. In other words, if I have a base class being caught, I need to say, well, the derived class, can this handler actually deal with it? And it uses RTTI, runtime type identification, to do this, which is somewhat expensive. It's not specified in the standard, but according to Andres, it's the way it's always done. And exception hierarchies are typically long chains and even multiple inheritance, right? So you can imagine all the work it has to do to go in and for any particular handler, follow these trees of exception hierarchies and figure out, is this something? So that's kind of expensive as well. And then we have, again from the standard, the implementation may then deallocate the memory for the object in an unspecified way, right? And if you've used the memory, which we will have, if you allocate and deallocate memory you never use, it's quick. But if you try and deallocate memory that you have used, which we will have, it's kind of expensive. So notice anything about this whole exception mechanics?
So expensive.
Yes, it's got expensive wrote all over it, right? Now what that means is it's maybe okay if you only use it here and there, or maybe you're in an application where you just don't care, right? Time is not of the essence. But yeah, it's expensive. So if an exception is thrown, during stack unwinding, your program is terminated with stud terminate. All right, now, it's not, where would that happen if exceptions leak out of destructors as you're trying to move up towards the handler? Or if your exception type itself throws an exception? I believe these all cause your programs just quit in mid-stride. But it also can be caught by a matching handler, and then the exception is no longer in flight. It's still alive till the last brace of the catch handler, but it's no longer in flight unless you rethrow it. And if no matching handler is found, stud terminate is called. And whether or not the stack is unwound is implementation defined. That's from the standard. And what that means is if you have stuff that you're expecting to be rolled back or given up or you've put some flag in your database, stud terminate will just call stud abort. I don't know where it actually does rewind. Yes, Faith?
No, you can throw during stack unwinding, you just have to cache it before it escapes.
Yes, but I'm saying if it escapes.
Yeah.
Yeah.
Yeah, so not if it's thrown, but if it escapes. Yeah.
Yep.
If it escapes, it's terminated.
So let's talk about exception hygiene. All right, what you should be doing with your exceptions. You should throw them by value. You shouldn't be throwing references for stuff on your stack because it's going to go away. You shouldn't be throwing raw pointers because, well, you shouldn't be using raw pointers for the most part anyway. So you should throw by value. And that value will get copied into this exception mechanism. So your copying shouldn't throw an exception either, right? Otherwise you're going to terminate. You're supposed to catch by reference, and that prevents object slicing issues and extra copies. Okay, now, some people say const reference. That's kind of a signal of intent. I'm not going to modify it, but it's a copy, so do with that what you will. And if you want to rethrow, throw with no arguments. If you throw with the argument that came in, you're making a new copy, and you can slice the object again. All right. And also the catch handlers are done in order of how they're listed out. So you want to make sure that the derived classes are placed before their base classes. Otherwise, you will never get to the derived class. Now, here we are in the middle of a function, 20 layers down in a stack. We hit the ejection button, throw. And we're rocketing up through the stack, laying waste to objects left and right. It's just like, chaos will ensue. So to protect us from this, I think it was a couple of guys with Dave Abrahams, who's unfortunately not here, right? They came up with this idea of exception safety to help us not have total chaos when the handler's throwing. Now, when the language was first being discussed about bringing exceptions in, there was a lot of talk, I think, about garbage collection so that memory would be automatically cleaned up, but it was eventually thrown out. So what is exception safety? It comes in 3 guarantees. The no throw guarantee, which says I will not throw an exception, or if I do, things are so bad, kill the program. All right. The basic guarantee, which says, listen, when I come out of this exception block, where the throw was happening, out of the function block, there'll be no memory corruption, there'll be no memory leakage, and all class invariants will still hold. Right. I don't know why that's special for this. I would say every function should be following this kind of guarantee, right? And then we have the strong guarantee, which is like the same semantics you have in a database where you commit and you can roll back if you don't. So if an exception is thrown, no data has changed, you get the same thing back. So this is our exception safety. And so that keeps us warm and fuzzy when we're throwing exceptions all over the place. Any questions on that?
The thrown value is the one that goes in the heap in general?
The thrown value, I believe, gets copied.
Into a heap.
Yeah, into the heap, into an allocated space on the heap.
Maybe. Maybe.
Hmm?
I said
Oh,
maybe.
sorry.
Maybe.
When you catch by const reference, could it be that you get a temporary created there?
No,
No, okay.
Why do you?
absolutely not. All right, so let's look at some of the drawbacks. I've been sort of rosying you guys up with how great exceptions are. Let's sort of look at the dark side of exceptions, right? They're unbounded in time and space, right? Especially with the nested exceptions and exception pointers, so exceptions now live beyond the life of the handler. You have invisible execution paths. It's not that easy to find where control is going in a place that's doing a lot of exception throwing. And you need exception swallowers, at least at your main, right? And then it has to be enabled in C++ because it breaks it flaunts the idea of you don't pay for what you don't use. Here you pay for RTTI and exceptions even if you never throw them. All right, so when this is the herb pie chart that shows that over half people are constrained in the use of exceptions. So that was a brief trip through the mechanism of exception handling. Any questions? Great, I got a lot to get through. All right. So let's talk about the philosophy-based view. What are the great thinkers of our time thinking on exceptions? They're sitting up in their towers or on the top of their mountains, sending the tablets down. What do they believe exceptions should be used for, right? Right, we talk about rare unhappy path events. We talk about non-trivial or exceptional errors. So let's take a look at that, right? And I have a couple of questions to thinkers of our time, right? So question one, when is it appropriate to use an exception? Right, so when I go to the guidelines, it says for runtime errors when a function can't fulfill its contract or do what it's advertised to do. So we'll throw an exception signal that we can't do what we said we would do. All right, this is one data point that would lead you very far astray if you just followed this one principle, right? It's appropriate to use it in constructor operator failures. You've been told it's a simpler way. All right, again, if you just use these two, you might be throwing exceptions all over the shop, all right? But I want to ask, what about undefined or unrecoverable system state, where we have memory corruption, memory exhaustion, bad allocations? Is this a use of exceptions?
No.
No. All right, people thought in the beginning it would be, but then we figure, if we've got memory corruption, I don't even know if I can unroll the stack, right? I just probably should get out of Dodge right now, all right? And again, going to design and evolution, you're trying to provide facilities that allow a single program to recover from all possible errors will lead to error handling complexities that produce errors themselves. In other words, you're doubling down and you're not getting.
Yeah, so see, use exception is a big term. I mean, does that mean throw, catch, or both?
Throwing.
Throw exception.
Because the guy who throws it initiates everything else, right? You can have catches and nothing happens, but you have to have someone who throws. And even if you don't want to use exceptions, if someone's throwing, you're pulled into it. So let me just do that question a little more. What are the use cases that exceptions were designed for? Right? And I think it's something like this. Program is encountered a situation that cannot be dealt with properly because it does not have enough context, but maybe someone above has. So let him handle it. This would be what I would call probably the mitigation strategy, where you're saying, I just want to kind of maybe get rid of the work I'm doing. The second one is we've encountered a real serious error, and proceeding forward is the worst possible choice I can have. I just went out of here. Or as one guy I talked to said, there's sometimes I'm in a place where things are going all wrong, and I just want out of here, right? Hit the ejection button, poof, off you go. I maintain, if you're using exceptions for something else, there's likely a better way. You're probably not using them properly. Anyone attack me over that? All right, good. Question 2. Are exceptions for very rare events only?
Hopefully.
Yes? No?
Exceptions, yes.
Maybe?
I think they're so costly that they have to be there.
All right, so again, going to the guidelines. Right, keep error handling separated from ordinary code, whatever that is, because and this is a funny sentence. C++ implementations tend to be optimized based on the assumptions that exceptions are rare. That should read they're pessimized on the assumption that they're rare. They're very expensive. Right. In the Microsoft guide for programming and exceptions, they say use exception handling if the event doesn't occur very often. That is, the event is exceptional. Right? In other words, make it rare. But who here can give me the upper bound for my flow of information through my system, taking an exception path? What is it, 10%, 5%? Does anyone actually measure this in their systems? Does anyone say, look, I want to know how much of my, SREs might have a glimpse in this, but how much of my code is going through exception paths on average when I'm dealing with my workload? I don't think anyone really does. Oh,
I mean, it's so close to zero that it's unmeasurable.
you think?
For sure.
And yet we say never assume measure.
Yes, I can assure you because I have that last chance exception handler and the program does not escape.
Yeah, but that's a last chance. You might be dealing with them all throughout your code base, right?
That's a longer discussion.
Yeah.
I have at some point tried to use it instead of optional. It's like 500 times slower. So it's
Yes.
slow.
Yeah. Oh, it's slow. So how do I handle frequent minor errors? Because we've said use them for rare events. What do I do if it's frequent minor errors? And how can a third party who's writing libraries know my relationship to that error? Know if it's frequent or serious for me? They can't. It's a hidden relationship, right? And if exceptions are seen as the way to do things, they're like traveling first class, right? Only some people get to do it. Other people are backed down into this inferior mechanism, we've been told it's inferior, of error codes and state, right? And if you use exceptions for a normal situation, like you're just throwing them all over the place, then how do I know when a real problem shows up? Right? It's hard to find. So the questions keep coming. Right? Am I at liberty to choose when exceptions are used?
Sure.
You said it, yes.
Sometimes.
All right, there's kind of like yes, sure, it depends. Right? Yes, if you're the one throwing the exception, and it's allowed. We had that graph to say you can't. There's plenty of places I know of that won't let you do that. And if it's a third party from your perspective, then no, you don't get to choose. Unless you catch, swallow, or repackage into a return code, which I believe is what happens in Google. Well, Google doesn't allow exceptions. Right? This big, huge software empire doesn't allow exceptions. Why is that? I mean, you can read all of this, but essentially what they're saying is we wrote the code that was not exception tolerant. And even if we write new code that is exception tolerant, we can't guarantee the exception doesn't escape into the non-tolerant code and take our system down. Now, I heard just before here there's some Sean Perrin ironclad rule that allows you to do that, but I guess Google haven't seen that yet, right? But this is their stance, we don't use exceptions. And I'll do a final word, and this comes from Bjarne, and I think this is excellent, and people should have at least this in their head when they're thinking about exceptions. That they're used primarily for error handling. They're not an alternate return value mechanism. Right? You don't find something and say, when I find it, let me throw it out so someone else can catch it and get the value. Right? It's expensive. You want exception handlers to be rare compared to function definitions. That means the absence of try-catch blocks are the strength of exceptions, not having them everywhere. And that exceptions occur infrequently compared to function calls. You don't use them very often, they're rare. All right. So what do I conclude after my thoughts? I mean, the big thinkers will probably come to me after this, but only use exceptions for functional recoverable errors, and prefer to keep exceptions as rare as you can, meaning they're for uncommon serious errors, not just for stuff you expect to happen a lot. And that's my brief run through the philosophy. Yes, David?
On the previous slide, what is a functional recoverable error?
One where your system can proceed safely.
Basically one that's anticipated.
Right. What it usually means is you junk that unit of work and you move on to a brand new unit. Right. So that's the philosophy-based viewpoint. And now we'll go, oh, sorry, more questions?
I actually disagree with that statement. So, like, I give you an example, like one of the examples where we use them. So we have a parser for our input configuration language. And the rule is if there is a parsing error, the program stops. But we log the error report. The logging and error reporting is done at the top.
Mm-hmm.
And it simplifies the code greatly if from the guts of the parser, we throw the exception packaged with like enough information of what exactly didn't parse. It goes all the way through multiple layers, gets caught at the top. The parser like does the logging and then aborts.
I will cover that use case in a favorable fashion, right? Later on. So, one of the few times I will be favorable, right? So the main part of this talk is about the usage-based view, because as I said in the foreword, exceptions to me are defined by the usage. You can put anything in an exception handler and throw it, doesn't matter. So how are we using these things? What are people doing with exceptions in real code, right? And what should people be doing with exceptions in real code, right? In other words, are people misusing or abusing exceptions? Well, the title of this talk probably gives that away. So let's talk about, I'm going to go through a series of situations. Some are fairly obvious, but I want to cover it to be somewhat complete. But they're all things I have seen in the real world, right? I can't put the full code on here for various reasons, but they're out there. All right, so I'm going to do this as a series of what's the situation. So we need to explicitly give back or release a resource acquired during an operation before leaving the function, or an exception gets thrown. All right, so we're going to have to do some resource management. So exceptions can leave the function at any time, potentially resulting in a leak, and we need to ensure cleanup. So the pattern we're going to look for is the exception block catches the exception, releases a resource, and usually rethrows the exception. So here's how it shows up. You'll notice the error handling does no handling of the error. This is purely resource management, so you're making it do double duty. So should we do that? No. Here is a real piece of code, in case you think I just got deranged and came up with something really bad. This is a real piece of code, I won't say where, working in production. All right, anyone see a problem with the resource management here?
Yep.
Right, so we have, hey, we're going to pull data out of a file.
If you're not using your laptop screen, do you mind putting it down?
I am using it, John.
Oh, okay.
Sorry.
No, we don't see any problems over there.
All right, so we see here that if we catch a streaming exception, we're going to close the file and rethrow. We catch a stud exception where hopefully that's where everything is derived off of. We're going to close. And then at the end, we close it. There's a problem in this function that someone didn't spot already, right? Anyone see it? What's the problem?
Return.
Catch all. No catch all.
No, you don't throw if you return.
It's not a catch-all. Anyone else?
Someone could have thrown an int or something. We
Yeah.
have no idea.
That's not it either. It's something more basic.
You don't close the file and success count.
Yeah, and the success one, we just return a code here, right? I didn't see this the first time. I said, this is so bad. I said I was blind to that. So then when I started working the slide, I'm like, hold on, we got a bug in production code here. Right. So what's the way to fix this? RAII, this is easy. You guys would know this, right? So I'll write a little file manager class which says, right, RAII, which really should be constructor required, destructor release, right? So I'm going to acquire the file when I open it, and then the file manager, when it destroys, will release. That means all that drivel up there goes down into this little small while loop, all right? And it's much easier to spot an error here. And if anyone adds, these things are generally not that small. They can be long, extra exit points, we catch them. So this is obvious stuff. Now, I do a thing where I write my slides. I don't talk to ChatGPT. I just write my slides, right? And then I go back and look for literature. And I looked at design and evolution. This is one of the things that was in there saying you should use resource management like this. So it was kind of cool that I came up almost with the same thing that Bjarne did as far as don't do what was done previous.
It's kind of sad that you had to.
Yeah. So, what is the conclusion? Prefer RAII over catch handlers for resource management. In other words, don't be using exceptions this way. That should not be happening. Now I'm going to talk about exceptional pass the buck. What do I mean there? Any problem whatsoever, throw an exception. Right? So exceptions allow the thrower to offload the problem to the catcher. And when I spent a brief stint in Java, I was like, it's a death of 1,000 cuts, right? With exceptions getting thrown. So users generally need catch blocks all throughout their code, because if you don't, what happens is that exception will travel to the top of the chain, probably get caught by ellipsis main, and wipe out that transaction. And you might want that, as maybe it's not that serious, so you need to have local error handling which catches these things and ignores them. Right. Or it goes right, so we need local handling to mitigate transaction wiping when this kind of thing is going on. And the pattern we should be looking for is external libraries, other modular functionality, expresses all problems via an exception. So how does code for that look? I can't show you code, like code just throws exceptions every which way, so I gotta ask a couple of questions again. Is having try catch blocks all throughout your code, even around multiple single function calls, okay?
No.
All right, that's a no. Is having exception swallowers all throughout your code base okay? Right, because you don't know what's going on. You're just taking on faith something went on, and maybe I can go ahead. So yes, as I expected, you guys would get the answer right, which is you agree with me. Part of the right, the part of the benefit of exceptions is the lack of try catch all throughout your code base. Right, it's ugly. You're swapping try catch for if statements. You're on the wrong trail. We already talked about it not being efficient because of the mechanics. Now, maybe you don't care about efficiency, but some people do. And again, how am I going to find unusual, serious situations if I'm throwing it for everything under the sun? Now, when exceptions were being discussed and brought into the language, there was a whole host of people that said, this is great. You know, we're just talking about we should have termination or resume semantics. There was one guy, Doug McElroy, who disagreed. And he said, right, a notable exception to the agreement for putting the exceptions in language was Doug McElroy, who stated that the availability of exception handling would make systems less reliable because the library writers and programmers will just throw exceptions instead of trying to handle the problem, right, or even understand it. And there was something only time will tell to what extent Doug's prediction is true. Anyone think this has come true? One guy? That's it. Who thinks it was false? 4 guys. So everybody else doesn't have a clue. You're just here for the ride. Okay. All right. Who was Doug McElroy? Because he could have been some just guy that wandered into Bjarne's laboratory one time, said it and wandered out again. No. Doug McElroy was, I believe, one of the fathers of Unix. He wrote a bunch of the, he invented macros, which I don't know if that's an appellate you want. But he also did a lot of the Unix commands that we have, right? But he said, who was this guy? Basically, Bjarne said I didn't make any critical decisions without consulting Doug first because he had a knack for being right. All right. And even though we went against him once or twice, he generally was right. So he's not a guy to just be dismissed lightly. So here's the pattern. What do I say? Prefer to use exceptions only for unusual, rare situations. I mean, they're serious. Something to really take note of. Any questions?
In some systems like Java, where there is exceptional pass the buck as a habit, you tend to have catches that translate, wrap, chain.
Yeah. There's a lot of repackaging until you get to the top where you log it and bin it.
Is there an exception to the rare exception try catch rule?
Well, there's some languages that'd be like Python and OCaml and stuff where exception handling is really easy and efficient, and you just throw exceptions willy-nilly. It's there's no, you don't have to worry about expense. Just let it rip. All right, but that's not C++. All right, let's talk about exceptional logging. Oh.
I've seen pass the buck used in order to translate across layers of abstraction. So I can't find a key in a map. Might mean something in a different semantic context if you're considering a JSON.
I have that exact thing later in the slides because I don't like what you're doing there. All right. So I addressed that problem a little further on. So let's crack on. So exceptional logging. What's the situation? The thrower is missing needed context for the error investigation. All right. So exceptions when thrown can be missing vital information that we need as developers to find out what's going wrong. So what do? We log the error with extra information in the handler and we rethrow. Everybody's seen that, right? Or we repackage the exception because it's a lot cooler thing to do, and then we rethrow that instead, right? And one, the reporting is deep in the stack, and the other is at the handler side. So number 2 might have a little edge over number 1. I don't like this because this often leads to thinking modes where the logging and the content define an exception type, where we would never make that mistake in other parts of the language. So the pattern we're looking for is there's login repackaging of the exception in the handler with extra information, and then we rethrow for the actual handler to do something with it. So how does that look? All right, here it is here. Right? Which of these functions is throwing? No one knows, right? So that's some drawbacks of the whole exception approach. We tried to do throw specifiers, it was a disaster. All right, so what does this do here? So if transmit name is the one that throws an exception, we don't know what the key was that came in, so we put this in the log file and we go search for it. Now, some people will go, what are we, Luddites? Let's do it the snazzy way. Right, so I'm going to have an exception which takes the extra information in its constructor, pilfers the log piece out of the current exception. Then when you call the .what on this, it will throw out this extra information plus what was ever in the other exception, right? So we've added a new concept with an exception type. I say a way to get around this is this radical new concept of a mutable string, right? Where I say, look, I'll catch it, I'll add my information, and then rethrow it. There's no extra allocation, there's no making a new type just for this. And what this will look like is something like here, right? Catch it, add to the what. I've hidden the vomit that would normally be in here inside of a function call, which is what you should be doing anyhow, so that you can just look at it and say, oh, look, it's adding some extra information. Anyone?
So about allocations, if you're doing something to the string, you will allocate new memory for the string.
Potentially,
yes.
So
you said without new allocations, there are allocations.
But the other way guarantees it, right?
Some standard exceptions, they don't contain strings, right? Therefore-
No, I don't. I'm not aware. I'm not a standard maven, but I didn't notice where you could actually mutate the what on a standard exception, which is beef number one with exceptions in the standard library, and I have a lot of beefs to roll out. Yes.
The point of what is it allows the author of the exception type to customize what is produced by the what string.
Mhm.
You make it a mutable string, you could be stopping over other stuff that would be generating what it's called.
Yeah, well, that's just buggy programming, right? I can't legislate doing bad things, right? You would just add to it normally. Yes, Brett?
Given you can't do anything functional with what anyway, why not just log?
That's what that will do.
And I mean, no one like really wants to parse a what string to figure out how to recover from an error, right?
No, the what string is not for a system. The what string is for us humans to pick up the pieces afterwards.
Right, right.
All right. So then, what is my conclusion for this, where you have this kind of logging going on? Use an exception type with mutable logging. There's a gasp. John.
That's kind of what boost exceptions is.
Oh, it is?
Yeah,
What?
it's a little bit different, but the idea is that it's not designed to be general purpose exception, but it's in a situation where you want to do some kind of troubleshooting, where you want to gather information, because, you know, if you have a low level function that say is trying to read a file, can't read the file, and so it wants to throw information, but it probably doesn't know the name of the file.
Yeah.
Which is what you want to know. Right?
So that's exactly why I would have something like this.
Yeah, so with boost exception, I think what they actually did is kind of invented a language where you could add information to the exception as it went up. So
I don't need a language. I just
file
need
is
this. I just need the simple exception type, right? So I'm a simple man. No complication for me.
And it doesn't work everywhere, but in like 2023, we have like tracing systems and stuff for that kind of use case too, right? Like,
Yeah. But let me cut you there because I have a lot to get on to and a lot to complain about, so I need time. All right. So next, exceptional checking. What's the situation? I have some kind of result and I want to verify that it's valid. If it's not, let me throw that exception. Right, so exceptions can short circuit the stack in a neat way. All right. And it's clean to read, even if it can be a bit expensive to execute. So the pattern I'm looking for here is the exception thrower as a void return function. So how will that look? Well, here I have something with a comment if problem throw. Right? Anyone have any problems with this piece of code? Yes.
You can't like react to the error.
Sure you can.
There's no catch block.
Correct. Someone said there's no catch block. This is the beauty of using exceptions. There's no catch block. It's really keen. Look, do a send, get a response, return a response. Easy to see. This is not so easy to parse down in your cognitive load. Where I'm saying, oh, look, I've got some, let's say this is local type handling. I still have my void problem function. Now what happens is it throws exception, I catch it. Starts things looking messy, right? And it looks like a shallow return. We're not going way up the stack, right? So here's the check response, and here's the error handling. Now, what if I just said, look, here is my check response, which says that, hey, I'm going to return an enum. It's not like I'm asking the function to double duty with the return value, right? Which is one of the complaints we have with exceptions. It's just sitting there doing nothing, right? So I'll just say if there's a response error, go and print it out. Sorry, I went too fast. All right. This thing here you can ignore. I just made the bad choice of using an enum class, so I have to static typecast and do this sort of fancy footwork to get a code out. But essentially, you've just made it a simple return value. It's more efficient, right? And I think it's easier to read. So what I say is don't use exceptions if the stack return is shallow. Prefer a return value instead, because you have the space to put one in. All right, great, let's keep going. What about the exceptional trier? And someone came up to me before the talk and was talking about this, right? I have potentially a temporary problem that retrying may solve. So it's not an exception that it's temporary, all right? So the exceptions can be caught and used as a retry counting mechanism. It's out there. Kind of messy, but I guess neat. All right, so the pattern I'm looking for, exception is in a loop and has a conditional rethrow. What does that look like? Something like this. What do people think of this? You get a lot of thumbs down, Lainey.
If throwing and catching catching is expensive, then doing it multiple times in a row is going to be very expensive.
Right. It breaks the rule, where we had up on top of the mountain, where we say it's expensive, don't do it very often. Here we're prepared to do it some retry count amount of times.
But if it's a retry, it's a somewhat expected path, and it shouldn't be exceptional in that case.
Right. It's not even so exceptional, and it's not something that we expect like maybe never to do. So it's just a bad way of using it. We're not using it for error handling. We're using it for trying to establish something that's temporary problem. Yes.
I think it's kind of a bad idea to try to reason about the state of your program after catching an exception.
Well, here I think it's probably okay. Andres.
What happens if connect takes some arguments that you move into the code?
Yeah, well, I mean, if you code badly, you're going to get, play silly games. Play silly games, win silly prizes. Yes, Alex.
And this kind of code, people actually write it. And it's easier for them to do it because instead of using a couple of ifs statement and trying to retry it and do something, they're saying, we'll just throw and we'll catch it in the end.
It's easy to do.
It's easy to write. It's horrible, but it's easy to write.
So let me show you what happens when we have even more stuff going on. So not only do we need to connect, we need to notify someone of that result. Right, now we have to start duplicating functionality with the try and the catch block. Right, it just gets messier and gnarlier. So what should we do here? Here's your conditional rethrow again. It's just got more stuff that's already in the try. So what I say is use a simple return value. I think you have a problem in your API, not really a problem with exceptions. You've just sort of taken the easy way out. You need to rethink your API. And look at we don't have any of the duplication. Anything that needs to be done to notify is done afterwards. The retry loop looks pretty simple. And it's efficient, right? We're not throwing exceptions. There's probably a sleep or something in there as well. So what do I conclude? Prefer to use a return status for loop control. Actually, if stack return is shallow, should not be there. Right? Just. What about exceptionally hard to find, which is you down there in the back, right? You say, look, I'm searching for something, and I can't find it. Right? So a clean way to indicate a function has failed to uphold its end of the bargain, which is I'm searching for something and I can't find it. It's to throw an unfound tantrum, right? If I can't find it, deal with it, right? If you don't deal with it, I'm taking your whole code base down. So what's the pattern I'm looking at here? Exception thrower is a search function that returns the object when found and throws an exception when it's missing. And that looks something like this. I'm going to look for an order here. This is all based on real code. I can't give you the exact code. It's too big. But here we can't find it. Throw an exception, the order's not found. And down here, we'll catch it and say the error's missing. Do we have anything in the language that would help here? Yeah, right, optional. Right, here we have the optional coming back, which denotes whether we have something or do not have something. All right, we can return stud null up. And then here we can say if there's an error or not. Again, more efficient. I think it's cleaner to read. Yes?
What about when we can reason about the code and assume that the value should be there? If it's not there, then it's a problem with the program.
Right. So
we didn't know there's a big value or something.
Let's assume, in your particular case, not having an order, someone sends something in and says, I want you to modify this order. Right? And they say, well, not finding it is a transactional canceling event. Then yes, you would throw an exception. But how can you know that if someone else is writing this function for find order, right? And again, it comes to that hidden relationship. Exceptions will work best if you know the whole relationship from the throw to the catch site to the context it's being used in. And that's missing a lot of times if people just throw it anyhow, right? Yes?
So sorry, this is the better API design, and if the user then says, okay, I want to throw if the optional returns false.
You could grab, we've things where return codes are repackaging exceptions and the other way around. Yes?
Why did you choose optional instead of expected?
Because I wanted to denote let me get to the next slide.
Oh, yeah.
Right, now, because C++23 is here and I won't use it for a long time, I played around with some monadic functions, which I think were not there on Clang, it was only there on GCC, but here, I can say, hey, you got a dot or else, which means if you don't get a value in the optional, do this lambda. So it does the same thing. So we can get kind of niftier and functionally as the time goes on, which is apparently a great thing. All right, so prefer to return an optional which indicates found or not found. That's the answer to you, Daisy. I told you to hang on a second.
She's asking something. She said there's another tag that's for.
Yeah, why not use should expect it?
I will get to that. You guys, I know you're an intelligent audience. like, hold your horses, all right? Let's go to exceptional data passing. Now we're getting into the interesting stuff, all right? So the handler needs to perform specific actions based on data at the throw site, which is not available at the handler site. So exceptions can, as we saw in the original design criteria, they can transformation up the stack to the handler. It's more expensive than a traditional return value, but it's easier to evoke and doesn't poison all your functions with having to push this value all the way up the chain, which is what you were saying, Fyodor, right? So what's the pattern I'm looking for? Exception contains data used to perform handler actions, as opposed to just a logging and reset. So what does that look like? It looks like this little beastie here. All right, see, someone snuck in some data into the exception, and then down here in the handler, they use that to do some operation on it. All right, data passing. What do people think of this? No opinion whatsoever. I thought this would be lots of aggressive people attacking me. This is way too sedate. All right, so what do I think of all this stuff? Well, I think, again, here's the expected everyone was asking for. All right. So it's a shallow return. Looks like a shallow return. I'm going to do an expected templated on my success data, which is the message, or this bad client, and then I do the apply data, it comes back through the normal return mechanism, and I can say if it has a value, we're all happy. Just dereference and send it. Otherwise, use the message. So here we're transferring more than just the idea of it being there or not there. We're passing back some failure data. Now, any questions on that? All right. Now, one thing that gets my goat and really kills me with exceptions is this idea of, every single little thing needs a type as an exception type, right? So here we have a set of 4 types where I have an exception bad client. I'm going to put that little bit of message data inside of it. I have an exception bad order. I'm going to put that little message in it. But because theoretically in my mind they're caused from different reasons, I name them different types. Even though I do the same send message on these things, functionally they're identical. Or I say, I'm going to put a format code in there because it's needed at the catch side. I get all these extra layers of classes built up for very simple stuff. We would never do this anywhere else in the language. So why not do something like this, right? An exception class has got a template parameter, right? Here it is down here, bit of data the user can put in, user-defined data, right? When I bring it, when I create it, I just put the string and the data I want inside of it, right? Actually, that shouldn't have a reference on it. And then I can just access the data at the catch site, right? No matter what it may be. And if I need to stuff some data in because I don't have the context at the exact throw, I'll use the mutable version, stuff the data in and rethrow it. Right? Anyone like this? Don't like it?
Don't like it.
Why don't you like it?
Because how can you catch my exception if you don't know what the data is and you don't care?
You catch would specify
Should
in the template.
I don't see why, that's not really a question.
You have to know exactly what the template type is.
Yes, and I'm going to address that. I think we do too much polymorphism, but we're not there yet, right? So here's what I had before. If I have a template class, this is all that happens, right? And then down here, no code had to change. I just didn't have to write a bunch of classes for every little piece of data. All right, so does that answer your question, David? So what do I say? What's my conclusion? If the stack return is shallow, prefer to return a stud expected of success data failure. And additionally, use a simple template to transfer different failure data. Don't bloat your code with a bunch of exception types. We would not do it anywhere else. Why would we do it here? Yes.
A difficulty here is that when you're writing a function, it's very hard to know what all the possible use cases are and whether they're going to have a shallow stack return or a long?
Yes, exactly, and we'll get to that. The relationship is hidden. I keep going back to this point, right? How does the third-party library writer know? He doesn't. He has to guess.
They.
Let's talk about exceptional control flow. This is a good one. Should get people good and riled up, right? Handler needs to perform varying specific actions depending on the failure that occurs, right? That's why we have the multiple catch blocks. Right, so depending on the exception type that's called, do something specific. And it's frowned upon in theory. We say don't use exceptions for control flow. However, the very design of these things with the polymorphic catching and stuff and the extra handlers, right, almost begs it to be done this way. So I don't know how you can be too upset about it when you design something to work this way. And then people use it that way, right? So what's the pattern I'm looking for? Many exception catch blocks on a single try. And potentially each has specific functionality as opposed to just logging and reset, which I would think is the pure way an exception would work. So what's that going to look like? Here. Anybody got a problem with this code? Yeah. I see a lot of this. Anyone? This is good, right? Okay. All right, so what I'm going to say is let me change it. Let me say, look, I'm going to have my exceptions as my exception processing class as a variant of all the exceptions that can be thrown. Right. And down here, I'm going to say my stud expected is my success data and the variant of the failures that can occur. And then I have the regular return mechanism, again, assuming we have a shallow return. Result has a value, happy path. If it doesn't, I use this really snazzy visit where I have a generic lambda, right? So no matter whatever comes in, I call the send hour on it.
Here, I would ask, even if that's just a short snippet, if you have 3 different exception types that all lead to the same code path, you don't actually have 3 exception types.
Yes, and I'm going to get to that in a minute, right? But we do see a lot of this, so I have to address it. Now, people might say, look, you were very cute, Peter. You put all the same stuff in each of the different blocks. What happens if they're all different? You know, how can the paradigm handle this kind of shift? It's like it's gnarly now. I'm going to send warning, send hour, handle bad client. Well, this little class, I wrote it in a previous project. I took it out of, I think it was C++ preference or whatever. And all I did was added a deduction rule. So what this does is you give it a bunch of lambdas it inherits off of. We pull down the operator parens, all right? And all I've given it is a deduction guide which says, move the data if you can, don't copy it. The one that's in C++ preference does the copy instead. So when I use this, I just say, look, if I'm off the happy path, I now have an overloader which has all of these lambdas for handling the various exception types. I'll just call the visit pattern.
I've done this in production before. Debuggability got worse, ergonomics got worse, compile times got worse.
So I only had one of them happen.
Sorry?
I only had one of them happen. Guess which?
Compile time.
Yes. If the list of exceptions get huge, it becomes a compile time problem, right? Which is why I'm going to tackle why we don't want big long string hierarchies of this kind of stuff, right? Because it's a problem of our own making. So what do I say in conclusion? If the stack return is shallow, prefer stud expected with an error type as a variant of the exception types. Simple, straightforward. All right, let's go now to the one that really probably annoys me the most. All right, exception hierarchies. So what's the situation? I have lots of different error modes, and I want to use exception types to represent each and every one of them. I have a really rich exception type hierarchy. Right? So exceptions can be many and varied, right? The type indicates some categorization of the problem. And we would normally expect the real data to be in the message. So in other words, the name of it, I found, doesn't transfer very much information to the use of it. So the pattern I'm looking for is for a single try block, we have many exception handlers doing the same thing, which we had in the earlier example, or a single catch handler for a parent class instead. So what do I mean? Here is the many handlers thing. I'll call it the many handlers problem. Anyone see an issue with this?
Redundant.
Hmm?
It's redundant, they're all doing the same thing.
Yeah, but forget about that for a minute, because lots of people do. All right? Something else.
Some of the exceptions derived from models.
Yeah, I got logic at the top and underflow and range are derived from it, so it'll never get caught. So when you got a list of, and I've seen lists of 30 of these, right? I got to rearrange this properly, make sure. There's one source of error, right? And here's the many handlers. How would I fix this?
Just catch STD exception.
That's right. Look, just catch the base class, right? Why would you do all these extra exception types for when it's just doing the same thing? The functionality of your use of the exception is the same. Now, have I solved the problem here? No. I got to go back into my code base and see what clown did this, right? Right? In other words, here is all these types that carry a message, which is the only thing I'm going to read in my log file if there is a problem, right? But they're doing a single function. I remember up at the base class, what are we doing? We're catching it and just doing the e.what. So why are we throwing all these? Why don't we just do this instead? Throw the base class. Why are we throwing the functionality? The usage should define what's going on. Why don't we do this?
But isn't the idea that exception is purely virtual and it's instantiated?
Exception is not purely virtual.
It is. It's what is equals zero. It is. It's what is equals zero.
That's not, you can instantiate it like this. Yeah, so the problem here is that we don't have any constructor that takes a string, right? One of the, dare I say, strangest decisions I've come across in the hierarchy is like, I don't know, I missed a few beefs, but this is definitely another beef, right? Why don't we have that here? So what I got to do is I got to back this thing off to a runtime error, right? Sadly, I have to back it off to a runtime error.
But is the originality of the author to give more context by having different...
What context does it give you?
I mean, division by zero is different than...
So what? You're handling it the same way, right?
Well, but you know how people will handle it.
Yeah. So it goes back to the cases where I'm not sure who's going to be able to deal with the different types of...
You're not dealing with them differently. If you were doing something different with each of these, like to handle them differently, I would say absolutely different types. You're doing what I call the control flow.
But that's the problem, because the library writer makes that decision, but it's the caller that decides.
That hidden relationship again, John, right? Yeah. Gets us all the time. So look, now we have a single function, because that's the single use of what we're doing with the exception in the catch block. Now, I have some questions. Yes, I have plenty of questions, right? If a catch handler is by the parent class, why is the thrower not throwing the parent class? Assuming he knows, right? Maybe if he doesn't know, I get it. But let's say it's your code base, you're writing both pieces of this. Yes?
Well, there's high coupling between the thrower and the catcher at a structure level and at the dependency management level too.
But you're not, you're just calling the what on it. That's not coupling.
No, like to build, you have to add dependencies so you know what the base class, what the child class is. Like you really can't compile unless you add dependencies because you have to know.
Are you saying you have to know the hierarchy?
You have to have it in your dependency list. If you're a catcher,
But I can tell you in most places that I've noticed where we use the stud exceptions, it's usually a runtime error. Most people use that lots of the time. Because all they're looking to log and go on to the next
I'm
thing.
saying there's a high coupling in design when you get more specific, whereas the base class is less coupled. That's all I'm saying.
I'm saying that's an illusion.
Well, from the build system level, it's not.
All right, okay. I'm not a build system guy, so maybe we need to talk
It's an
after.
illusion in the code, it's not an illusion.
Right. So why are there any derived classes at all, right, if we're not using them to do control flow, do something different? And if the catch handler is performing the same operations for different exceptions, why are these not represented by a single exception class? Right, so you see I'm trying to take out the hierarchies here. Yes?
Sometimes you might actually want to use like a virtual method, polymorphic dispatch, like a different...
Yeah,
class.
so you're doing something different, that's fine. New class if you're doing something different, just when you're doing the exact same thing. All right, this I think is a pivotal way I want you to think. How is exception being used, not what am I theoretically believing caused it, right? Now, I still have more questions. Yes, I'm a simple man, lots of questions. So, stud exception has no string constructor. And this is the ideal place to ask why, because I do not know. All right, now does anyone know, or are you just guessing? Because I had a few guesses.
It's designed to be a base class, it's not designed to be...
Does it have a string inside
If
it?
you have a string, you call runtime here instead of a string.
But why?
No, I think it's because you might want to derive something that doesn't allocate.
No, you did. The exception has the string inside of it. Yes, David.
No, the exception doesn't have a string.
What is it? Where is the string?
It's a virtual function called what? Whatever
Ah.
inherits from it.
Okay.
I think that allo doesn't have.
If I did this with any other class hierarchy, you'd have my head. Okay.
String is not in the exception, it's stored somewhere else.
All right. I don't even know where it is. Right. It's so bizarre to me. Yes,
Bad
Eduardo.
allo derives from exception, right? And you don't want to allocate in bad allo because you probably cannot allocate in bad allo.
Right.
You need the string somewhere.
Use those tags string.
You don't need a string.
It's a
chart. It's pointer chart.
Okay.
You can have an integer error code in your what, you just do a switch and
That's
it's
It's a static string with PET value.
Okay. Well, thank you. That's maybe I'll rephrase some of my vitriol on this going forward. So what does runtime error do? Well, I went in and looked, and it says the class runtime error defines the type of objects thrown as exceptions to report errors presumably detectable only when the program runs. Not giving us any hard information here, just like, presumably, might, could happen. Kind of gets you to go away. What about logic error?
That is a logic error. You should not throw logic errors, you should assert them.
So, yeah, but we can throw them, John. Right? I can be a master evil genius and throw logic errors. Right? So, what is a logic error? Well, let me just read this out, and I'll get to you guys. The class logic error defines a type of object thrown to report errors, there's that word again, presumably detectable before the program executes, such as violations of preconditions. However, we're only coming across it during the runtime of the program, right? Right. So why would we can find these things? Why? So what is the difference in operational functionality between these two classes?
One shouldn't exist.
Too late, John. Genie's out of the box.
Catch them if you would have better type systems.
So these classes are identical in everything but name. There is no difference other than the text replace of the name. Yes, now who wants to come after me? Roy.
So you mentioned the fact that if there's memory corruption or something, there's practically no use of trying to keep going. So I think that logical error sometimes is the same, where there's an indication that there's no use in to keep going, and that's the...
No, I can say the runtime. I can fit runtime into the same argument.
No.
Yes. Talk to me afterwards.
So stood logic error was introduced in the language at a time when people were thinking that if you detect a defect in your program at runtime, that you would throw the stood logic error. But there's been very strong consensus after that if you detect a defect at runtime, you have an assertion failure, you terminate your program. So that's where this is coming from, is that generally people think stood logic error is there to maintain old code, but it really shouldn't exist and nobody should be using it in new code.
Okay, great. So get rid of it. I would love that. Right? I hate these two things together. Right? But one thing I will say, right, is that runtime error, is that really a good description of this class? Stood runtime error? It's horrible. It should be runtime logger or something. It should be exception logger. That's what it does. It doesn't do anything else. All right, now.
So, in the case where you're using exceptions to roll back transactions and continue, catching the runtime error is where you would do that. But you would separate catching the logic error for shutting the program down. That's why you separate type.
No, I would never shut my program down. I work in Bloomberg. If I shut my program down just for someone throwing a logic error, I'm looking to put my resume in this room here.
Because you're bleeding money as those logic.
You cannot have exceptions take you down in non-fault tolerant environments. Yes.
So earlier, I thought you argued that you should separate exception handling from logging, and if that's true,
I never said that.
Okay, I'll say it. I think maybe you should separate exception handling from logging, and in that case, exception handling is really about is really targeted to the program, not to a human who's going to look at logging. And if you take that philosophy, then that kind of alters.
But I think that philosophy is fundamentally flawed because with exceptions, we primarily use them to bin a piece of work, erase an error, and put it in the log for the humans.
Yeah, and
right?
that's primarily because programmers are idiots, right? I mean, because
I'm a programmer.
Look, you said that I did. But the thing is, right, when you...
I assume you are too.
I used to be. So when you use catches for exception, for logging, right, you get a throw, and then you catch it, log it, package it up, rethrow, catch it, log it again, and then you get these logs that are massive and not understandable.
Yeah, I mean, if you keep catching, and I've seen a system where there was so much handing of work off to different threads that every time they caught an exception, they logged it and threw it. And it brought the system to its knees. Its performance was horrible. Right? And all the exceptions, I tore out most of the exceptions out of it, right, to make it work. Okay, I still have to get moving on, but I'll take one more. So
just because it's the first time I want to contradict you about the logging, because I agree that runtime error, because it has a string, it will probably do something with that string, and what else can you do but log it. But you just said that exceptions are generally used just for logging.
I said in the main, yes.
But there's one thing that came up a lot in your examples, which was this problem that if you have code that has a very shallow stack depth, stack, then you can return directly an optional or an expected, and then let somebody else deal with it. So for me, exceptions are the message. I don't ever have messages in my exceptions, but what I do use them for is for that exceptional stack exit to say.
Right.
The file error happens somewhere very far down, but the handling has to happen.
Yeah, and we're talking. You're talking about stack traversal, which we are going to get to, right? So again, these are identical in every respect. So I decided let's go back to basics on this one because again, there's a lot of controversy, and I'm going to go to Shakespeare. All right. And popular, I don't know, maybe it's not so popular over here. It is in Europe. A rose by any other name would smell as sweet. Right, that's from Romeo and Juliet, the great guy Shakespeare. This reference is used to state that the names of things do not affect what they really are. In other words, I could say that's a penguin, right? But it's still a rose by any other name. Now, that might be a little too artsy, so let's go to something a bit more concrete. And if anyone's ever seen me at CppCon, my little thing says, if it walks like a duck, quacks like a duck, don't tell me it's not a duck, all right? So what does this mean? This means that something is identified by its habitual characteristics, not by whatever random name you put on it, right? And here's a little picture here, right? This could be a rabbit in disguise, right? But it isn't, all right? Right, so think of your exceptions as how they're used, not how some intent that you want to have, sort of that's some sort of boffinish intent you have, all right?
Nobody knows what that word means.
Very professory mindset. So what do I say? I say, and I'm not expecting universal acceptance. Throw a base class if the catch handler is a base class, and you have that control. Additionally, prefer a single exception type catch handler if the operations are the same inside multiple catch handlers. So are you seeing that 3 different exceptions that just did a send? You're like, why is there 3 there? Why not just 1 exception type? So this should all start squashing down and getting rid of these huge hierarchies of exceptions. So that was my brief romp through the usage-based view, which, as I said in the beginning, what defines an exception is how they're being used because there's nothing else to go by. So let's talk about exceptional that's unwindy, not unwindy. All right, exceptional unwindy. So I see that this is coming to stack traversal. There's 3 categories, I think, of stack unwinding. The exception terminates the process. There is something where, I don't know, maybe I'm coming up and I can't get to the database, so I can't load state, right? And that's like so bad, I need to exit. So now I could do it way down in the stack and just say exit, but that's bad manners, terminating someone else's process, right? So you just send it up, it gets caught, and we say terminate, can't connect to database, or whatever it is that's so bad. The other thing we have is the transactionally fatal part of a stack unwind. In other words, this will come up somewhere towards your main processing loop, and we'll say, hey, this piece of work is toast. Right? Send an error back saying I can't handle it, do whatever, do some notification in your log file, and now take a new unit of work and hopefully it's a better day. All right? And then the last category is local error handling. Right? Now this can be used to erase, mitigate, recover from exceptions. I've seen it where someone is using a third-party library which throws an exception if there's duplicates. And they're like, if that goes all the way up to the top, it wipes the exception or wipes the transaction out. But they're like, this is something we sometimes it's there, sometimes it's not. We don't care. Maybe if we're the first, we'll create, if not. Right? It's probably a misuse of exceptions. And again, it comes back to that hidden relationship as to the return depth. If you're isolated writing the throw. And if the stack return is shallow, I keep saying you should probably handle without an exception. That there's better ways to do it. Anyone want to comment on this? Yes, you
So
again.
What are you saying? Are you saying that when a third-party library throws, you should catch it and then return the error?
No, I'm saying the third party doesn't have enough information to know whether we should throw or not. So, let's talk now about the truly exceptional, right? It's like looking upon the divine, right, with exceptions. All right? What should they be used for? And I say it should be used for error tracing and logging. And if that's one of the main things we do with these exceptions, then why don't we optimize for that? What is the error? We have that, right? What's going on? Where in the code is the error? We can use stud source location to give us that information. And in 23, we can say, where in the stack are we when this error got thrown? Right? We can use the basic stack trace. There is some paper talking about getting a static function that can get a stack trace for exception. Seems woefully complicated, so I'm not a fan. All right. What's the other thing we use with exceptions? Stack unwinding, deep stack returns, right? Your parser, I forget what you were doing, Sebastian, but whatever it was, right? Use it for deep stack returns. In other words, I'm terminating a process or I'm terminating a current transaction or unit of work. And the last thing, control flow. Yes, it happens. We have programs in the real world that need to do different things based on the exception, which is control flow. Encapsulate control data. Yes?
That was my point earlier, your first bullet point. We have tracing systems that are better at tracing than exceptions.
Well, you better bring them to ticker plan. You need to bring them to ticker plan, right? Because I haven't seen them in the one.
We have many, but yes.
All right. And do all of this without long, repetitive, duplicative class hierarchies. Can it be done? Can we have an exceptional exception class, right? Well, I don't know who said, I am the alpha, I am the omega, right? All things will come to me. Boom, here it is. My idea of the perfect, well, it's a slideware, so it's not exactly perfect. But something that gets the job done, I think, of basically every exception scenario I've ever had to use. So what do we have? Let's look at this beastie and examine it, right? First thing we have is some place to put user data. So we're not writing big, long chains just for different data types. Have the constructor, there's a couple of them in my actual Godbolt, but this one just moves stuff in, right? And you see stud source location just gets the current place in the code where it's been instantiated, and same with stack trace. So once I have that, what can I do with this thing? Well, I have the mutable what, right? You want to add stuff in as you're going along. It's not a one size fits all. I have a source location. Where did this happen? I have a stack trace. It took a little work in Godbolt. I don't think it's in Clang yet either. But in version 23, we have this. And we can now pull these things out. And I think it's great. I love it. Right? And then we have the user data. So we can access the data or whatever. I think, prediction. I have a seer mentality. Prediction. If something like this gets used in code bases, people are going to weep when they look at a log file and see a regular runtime error. Right? Give them the information. Just be like, what? I have no idea where it went. I'm going grepping, going through the source looking for it. Don't know how I got there. There's multiple paths in. They're going to say, man, I wish I had the Omega exception class sitting around. I got to say, Pete Muldoon really nailed that thing.
They'll work for everywhere except for out of memory. If it doesn't fail,
out of memory, we said, is not an exception thing. Out of memory, I'm not handling because exceptions don't handle out of memory. Yes.
I would argue to make it incrementally more useful, you could put the location in the stack in a non-template based class. That way that you have access to that as a single.
Glad you brought that up, because this means no RTTI running around up through inheritance trees, right? This is just, you get there, there's no one else you can go to, boom, you take the RTTI tracing out. But yes, if you wanted, you could take parts of this and say, well, there's some types I don't need to put my own data in. Yeah.
How do you catch that?
Hold on a second. Let me get Andres, almost my mentor for this talk.
And you already know what I'm going to say. It's not a class, it's a class template. Could
Yeah?
we type erase the data, please, and make it a class?
No. I do not want to type erase the data. That's a form of data hiding. Strange things. This is simple. I'm a simple man. This is just how I do things, right? Let me get Brett over here.
Yeah, I'm going to reiterate the coupling. This is great if my dependencies already have a dependency on lib omega or wherever you put that thing.
Dependency on what?
Well, part of the point of the exceptions is you can kick it from one place and give it to another place, right?
Mm-hmm.
Like both places have to have a dependency on the type. So the thrower and the catcher both have to depend on the lib omega.
That's an agreement you always have to make. The thrower can't throw something the catcher doesn't know about.
So you're having an additional qualification, which is exceptions only work.
I'm going to show it in use. Maybe in use this will. Is this something theoretical, or can I show the use case first?
Well, which one do I get to talk with? 'Cause
Actually, let me show it in use, and then we'll have a bit more discussion because I'm running low on time. Right? So I have some utility functions. I think it sucks the way stack trace gets printed out normally. Shows you stuff that you don't care about. So this is the way I just put these together. Now let's look at this thing in action. Prepare to be amazed. Yes. You can't come in yet.
Why is it a class and not a struct? Doesn't have anything to hide.
I don't care. Right. So let's look at this thing in motion. Right. Look at a cheetah. It doesn't look very good. You look at it like bounding across the. Man, that's really good. Let's look at this thing in motion. So look, here I am creating exception classes from my exception template. Right. And I say, look, I'm doing it in a couple of enums. Either type doesn't matter. I say, look, throw an exception, bad order ID, and it's real bad. That's my enum, right? Down here, I say, look, catch my exceptions are 1, so you don't have to catch. You can have that refinement through the templating. And I'm going to say, hey, look, it failed to process with code 2, which was real bad, right? And it happened in this place in the code on this function. Isn't that nice? Everybody go, All right, I'll make you even more impressed. All right, watch. Look, I have this bucket of data. I need to do something with this data. I have a bucket of data, just a simple one with a message and an ID, templated on this class. One size can be used everywhere. And I just throw this damn thing. Here's a bad error, and here's a bucket with a client ID and a message in it. And then I catch it, and I say, look, I failed to process this. I reach into the bucket for the ID, print a stack trace, and then I do the send error with the little message inside like we had before. And here's what you get out. Failed to process ID 222, and here's the stack trace of how it was done. All right. Sean, do you still have a question?
I never had a question.
Oh, you scratching your ear vigorously. It looked like this. Now, David.
Okay, so 2 problems. So the first one is that you have to know the data type in order to be able to catch the exception.
No, this is the type here.
No, I'm talking about the template parameter. If I don't give a crap about your exception bucket, and all I care is if any kind of omega exception got thrown, I have no way to make a catch block to be able to capture that exception. You can fix this easily. Just give it a base class.
I know, yeah.
Okay, so fix that. Second one is that. So the second one is that at a company I previously worked for, I
would have no idea.
There was a fairly serious outage.
Yeah.
Because there was a system similar to this where they were logging stack traces, which tend to get pretty big, and it can fill up your hard disk fairly quickly if you happen to have exceptions firing.
I know where you used to work, and I know we produce tons of log files anyway. So.
Well, I can tell you,
And this can be, you know, like you want to put a trim and say, like, I only want the X of the stack trace, then fine. You don't even have to call the stack trace.
Well, let me tell you, if you want to make this work in a real world production system,
Which, yes.
you want to make sure that you're, instead of outputting the entire stack trace, you want to output that encoded and then be able to use the executable to be able to get the pretty parts.
Or maybe where you worked had a tracing system that you just use that.
I think that tracing system came about.
So David, I would not do unless I was design constrained. In other words, I can make this class more complicated and fit in those constraints. If they are not in my current environment, I'm not doing it. Right? I'm not making a class that is a lot of weird stuff going on in it for a hugely irrelevant corner case.
Yeah, I get you.
And that it comes down to a value judgment, right? So yeah, you could be right. So look, I've only got a couple of minutes left. In conclusion, we've done this long journey. It's been entertaining, it's been great, but we gotta close the show, right? Exceptions are defined by the usage. That's the thing I rest everything on now, right? And I thought there was no place for exceptions, but I was wrong once I started digging in. There's a little spot for them, right? So what should they be used for? Error tracing and logging, so you help investigation. Stack unwinding, coming deep stack traversals because you don't want to contaminate your whole return value stuff to try and carry a value back. Data passing and control flow when necessary. Being able to pull data from a throw site all the way up to a catch so you can properly handle the problem. So that's what they should be used for. When should they be used? Well, I think as rarely as possible. For serious, infrequent, unexpected errors. And with as few exception types as possible, determined by the functionality used in the catch, not what's running around in your brain. Preferably with the above exception. Gotta give myself a plug, all right? That's it, guys. I have no more to say on exception. Thank you for coming here with such a good audience. Now here's other engineering talks, all related to the real world, if you want to look and see some of my other zany humors. And here is a bunch of Godbolt examples if you want to see what I did, all right? Now, we have a couple of minutes for questions, so you haven't asked me one up to now.
So there was that part where we talked about the difference between runtime error and logic error.
Mm-hmm.
You quoted the spec saying catch invariant mistakes before the runtime of the program. What is that? What's before the runtime of the program? I come from an environment where we focus RTCI before the instruction.
Yeah, so what they mean there is that you should have spotted it up front. So your error shouldn't be in your code. At least that's what the thinking was at the time, which is more or less impossible. Right. All right, next. We've got limited time. Jeff.
So, unfortunately, there is measurement in the real world in a paper before the standards committee that shows that using expected is slower than exception.
I am actually waiting for someone to show me some code where the throw is still expected. And it's going to happen. Email me.
So just be aware.
Email me here if you have it, right?
Just be aware, measure the cost.
Yes, you always measure, always measure. Oh, sorry. No, actually, stop. Brett was in front of you.
Sorry. So I'm going to illustrate my point. You have the thread pool team has a library that is used for thread pooling. Right?
I don't, but yes.
Hypothetically. The database team has a database library used for database thing. All the peak codes in the middle, right? And so the database team wants to throw, and the thread pool team wants to catch and log. How does a mega fit into that picture? Or is there a mega exception for that? It has to be lower than all of those pieces of code.
All that you're saying is there has to be an agreement made of what's thrown in one part of the code and what's catched in the other, which is always there.
There's a where in there that
If I throw a runtime error.
When should you do exceptions? And the exception should be a common exception for the catch and the thrower. The other guy can actually maybe skip it, but the catcher and the thrower, they both need to have like a common vocabulary exception. So a mega exception is only useful if it's a common dependency among all these systems.
No, but that's exactly the point, right? In other words, you can't.
It's very important though, because people write libraries where they're throwing my database exception. Like,
Yeah.
well, how's the threat pool guy going to know what to do with that? And that's what part of these base class work around this.
Hold on.
Part of these base class work around it, but as you pointed out, there's problems with it.
No, but that's, I think that's a somewhat specious argument because you can't, two pieces of the system that are supposed to talk to each other have to have some common channel of communication. They have to understand something that's happening on here. That's what's you're going to see over there.
That's
You
what I'm saying.
can't, they can't work in a
It has to be
vacuum.
low enough level dependence, like ask a vocabulary exception. That's the look at vocabulary. We're all agreeing this is the exception we're throwing and catching in that context. Otherwise, you have all these problems we're talking about.
Yeah, and I think, again, it comes back to that hidden relationship of I'm throwing something. Does the guy who's catching it know what I'm
Well,
doing?
practically, like testing. If you want to catch it, you want to test something through the way it was supposed to throw in certain circumstances.
All right, I want to cut you off there a second.
Your
All right.
vocabulary type for that exact situation, since you don't know, since basically you've got two libraries, this guy's throwing, this guy's catching, because he has to marshal the exception, presumably to somebody else who knows how to handle it. Neither of these have a dependency on each other. That's exactly what exception pointer is for. So I can catch ... I can give the exception pointer, and then I can marshal that exception to whoever can handle it correctly.
And I will have you know the omega will fit into an exception pointer.
Yes.
I've checked that one out. Okay. All right. Do we have more time, or am I out? I know the clock's disappeared, which makes me. Right. Okay. We're out of time. I'm around all week. Thank you.